It is December 1942, and somewhere in the grey chop of the North Atlantic, a merchant vessel is going under. She takes 3 minutes from the moment the torpedo strikes to the moment her stern vanishes beneath the surface. The men who survive do so by luck alone. The water temperature is 4 degrees Celsius, and it will kill a man in under 10 minutes without a life jacket. Far above, at 30,000 feet, a German Focke-Wulf FW-200 Condor banks slowly away into cloud cover. It has seen everything. It radioed the U-boat, and now, its work done, it turns east towards occupied France. There is nothing the Allies can do to stop it. This scene repeats itself hundreds of times in 1942. It is the worst year of the Battle of the Atlantic. German submarines are sinking Allied shipping faster than it can be replaced. More than 1,600 merchant vessels are lost that year alone. The food, fuel, and ammunition flowing to Britain are being strangled at sea, and without that lifeline, the war effort, perhaps the war itself, will collapse. Winston Churchill will later write that the U-boat threat was the only thing that ever truly frightened him. Not the Blitz, not the fall of France, the submarines. The problem, reduced to its brutal arithmetic, is geography. Allied land-based aircraft can protect shipping only so far from the coastlines of Britain and North America. Beyond that, in the mid-Atlantic stretch, known as the Black Pit or the Air Gap, convoys sail without air cover for days at a time. The Condors hunt there freely, the U-boats gather there in wolf packs, and the Allies have no answer, because what the convoys need in the middle of an ocean is an airfield. You cannot build an airfield in the middle of the Atlantic. But what if you could grow one? What follows is the story of Project Habbakuk, one of the most extraordinary, eccentric, and genuinely brilliant weapons programs in the history of the Second World War. It is the story of a material invented by a man who kept mice as pets and fed them wood pulp, of a prototype built in the Canadian wilderness by conscientious objectors, and of a vessel so vast it would have dwarfed any ship ever constructed, made almost entirely from frozen water. It is a story that sounds like fiction. Every word of it is true. To understand why Habbakuk existed at all, you must understand the scale of desperation that produced it. By late 1942, the Royal Navy and Royal Air Force were fighting the Battle of the Atlantic with every tool available to them, and it was not enough. Escort carriers, small aircraft carriers converted from merchant hulls, had begun to appear, but they were few in number, vulnerable, and expensive. They required steel to build, and steel was in desperately short supply. Every ton that went to a carrier was a ton that could not go to a tank, a ship, or a gun. The standard fleet carrier of the era, such as HMS Illustrious, displaced roughly 23,000 tons and required the full industrial capacity of a major shipyard for 2 or 3 years of construction. Britain had neither the shipyards nor the time. The United States, theoretically a more powerful industrial partner, was itself overstretched, pouring resources into the Pacific theater after Pearl Harbor. The ships Britain needed simply could not be built in time, from materials that were not available in yards that did not exist. The air gap, meanwhile, remained stubbornly open. Very long-range aircraft, particularly the consolidated B-24 Liberator, modified with additional fuel tanks, were beginning to edge their coverage outward, but even these could not close it entirely. What was needed was a floating airfield, something large enough to land aircraft, refuel and rearm them, and send them back into the fight. Something that could be positioned in the mid-Atlantic to deny the Condors their hunting ground and the U-boats their sanctuary. Every solution that presented itself ran into the same wall: steel. There was not enough of it. Aircraft carriers needed steel in quantities that the Allied war economy could not sustain without sacrificing other critical programs. Someone, at some point in 1942, needed to think beyond steel entirely. And someone did. Geoffrey Pyke was not, by any conventional measure, a military man. He was an inventor, a journalist, a pamphleteer, and a thinker of almost manic originality. He had escaped from a German internment camp during the First World War by pretending to be a neutral American. He had, in the late 1930s, proposed sending a team of statisticians to fascist Spain, disguised as tourists. He was, by all accounts, infuriating to work with, difficult to categorize, and occasionally impossible to ignore. He had been attached to combined operations under Lord Mountbatten, and it was there that he produced the idea that would consume the next 2 years of his life and the resources of 3 governments. Pyke's insight was disarmingly simple. What if the floating airfield were made not from steel, but from ice? Ice was abundant. It cost nothing to produce in quantity. It was not rationed, not scarce, and not subject to the competing demands of tank factories and shipyards. A sufficiently large block of ice, Pyke reasoned, would be stable in the North Atlantic, difficult to sink, and entirely capable of functioning as an aircraft carrier. His memorandum on the subject, submitted in December 1942, was characteristically dense, discursive, and visionary. Churchill read it and famously sent back a one-word response: Habbakuk. The name came misspelled from the Old Testament prophet who spoke of works so astonishing that men would not believe them even when told. There was, however, a problem with pure ice. Pure ice is brittle. A torpedo strike, or simply the relentless pounding of North Atlantic seas, would crack and shatter it. An aircraft carrier made of plain frozen water was not a vessel. It was a liability. What Habbakuk needed was not ice alone. What it needed was a new material entirely. The solution came from an unlikely source: a set of experiments involving wood pulp and a colony of mice. Pyke had read a paper by an American scientist, Herman Mark, suggesting that the addition of fibrous materials to ice dramatically improved its structural properties. Working from this principle and drawing on experiments conducted in his own kitchen using a domestic freezer, Pyke's team began testing various admixtures. The material they eventually settled on was a mixture of approximately 14% wood pulp, essentially the same material used in newspaper production, and 86% water, frozen together into a composite that behaved in ways pure ice simply could not. The resulting substance was named Pykrete in honor of its inventor, and Pykrete was remarkable. Where pure ice shatters under impact, Pykrete deforms slowly, like a very cold metal. Its compressive strength, the force required to crush it, is roughly comparable to concrete. It melts at an extraordinarily slow rate. A block of Pykrete, the size of a kitchen table, placed in a room at normal temperature, will hold its shape for many hours, losing surface material gradually rather than collapsing. When a pistol is fired at a block of Pykrete at close range, the bullet does not pass through cleanly. It slows and flattens, its energy absorbed by the wood fibers suspended within the ice matrix. which act rather like reinforcing rods in concrete. Lord Mountbatten, demonstrating this property to Winston Churchill and the Allied Chiefs of Staff at the Quebec Conference in August 1943, famously fired a pistol into a block of Pykrete in a hotel bathroom. The bullet ricocheted, narrowly missing one of the observers. The point was made. The proposed Habbakuk vessel, referred to in planning documents as Mark II, was designed on a scale that seems almost hallucinatory. The working specification called for a vessel approximately 610 meters, 2,000 feet, in length. For reference, HMS Queen Elizabeth, the largest aircraft carrier in current Royal Navy service, is 280 meters long. The Habbakuk would have been more than twice that length and vastly more massive. Its beam, its width, was projected at around 90 meters, 300 feet. Its displacement was estimated at 2.2 million tons, a figure so enormous it bears repeating, 2.2 million tons. The Titanic displaced roughly 52,000 tons. The Habbakuk would have been more than 40 times as massive. The hull would have been Pykrete throughout, with walls some 12 meters, 40 feet thick in some sections, thick enough to absorb torpedo impacts without structural failure. The vessel would have been self-refrigerating, with an internal network of pipes carrying coolant fluid through the hull to prevent the Pykrete from melting in the relatively warm waters of the mid-Atlantic. This refrigeration system would have been powered by a series of internal engines, themselves housed in insulated compartments deep within the hull. The outer surface of the vessel, naturally, would have been in constant contact with seawater at temperatures that rarely exceeded 10 degrees Celsius, providing a natural cooling effect. Propulsion was to come from nacelles, external drive units, housing multiple electric motors powered by internal generators. The vessel would have been capable of roughly 7 knots, which was slow by naval standards, but sufficient for positioning. It was never intended to chase enemies. It was intended to sit immovably in the middle of the Atlantic, and from its deck, which would have been large enough to operate Spitfires and Hurricanes, project air power into the Black Pit. The refrigeration plant alone would have required an installation roughly equivalent in scale and complexity to a large land-based cold storage facility. The workforce required to construct the vessel was estimated in the hundreds of thousands. The Pykrete itself would have demanded enormous quantities of wood pulp, and the freezing process would have consumed electrical power on a scale that strained the imagination of the project's planners. To test whether any of this was feasible at all, a scale prototype was commissioned, a vessel of roughly 1,000 tons, and built in secret during the winter of 1942 to 1943 on Patricia Lake in the Canadian Rockies near the town of Jasper, Alberta. The workforce consisted largely of conscientious objectors, men whose religious convictions prevented them from bearing arms, but whose labor was nonetheless directed by the state. They worked through the winter in temperatures that fell to minus 30 Celsius, constructing a vessel 60 meters long and 9 meters wide from the Pykrete they manufactured on site. It floated. It held. It did not melt during the summer that followed, demonstrating the remarkable insulating properties of its own bulk. The prototype survived until 1943, by which point the project had moved on to larger questions. If you are finding this interesting, a quick subscribe helps more than you know. Habbakuk never saw operational deployment. The Patricia Lake prototype remained the only physical realization of the concept, and the reasons for the project's eventual cancellation are a useful mirror for understanding both its genius and its limitations. The Germans, for their part, had nothing remotely comparable. The Kriegsmarine and the Wehrmacht's engineering apparatus were formidable in many respects. Their submarine technology was genuinely world-leading, and their work on rocket propulsion would shape the next half-century of aerospace. But nothing in the German war records suggests that the concept of a Pykrete vessel was ever seriously entertained. The German approach to the mid-Atlantic problem was offensive rather than defensive. Rather than protecting Allied shipping, the strategy was to sink it faster than it could be replaced. The idea of building a floating airfield from frozen wood pulp simply does not appear in any known German document of the period. The Americans, by contrast, engaged with Habbakuk seriously and enthusiastically, at least for a time. American scientists conducted their own Pykrete tests and confirmed the British findings. American planners considered the vessel's potential applications in the Pacific theater, where island-hopping campaigns required air cover over enormous stretches of open ocean. The U.S. Navy's Bureau of Ships produced analysis that broadly supported Mountbatten's enthusiasm. At the Quebec Conference of August 1943, attended by Roosevelt, Churchill, and the combined Allied chiefs, Habbakuk was formally presented as a viable, war-winning technology. But viability, it turned out, existed on a spectrum. The American conclusion, delivered with characteristic bluntness, was that Habbakuk could be built, but that doing so would require a commitment of resources so enormous as to crowd out other equally critical programs. The steel for the refrigeration plant alone was estimated at hundreds of thousands of tons. The wood pulp requirements would have competed directly with paper production and other industries. The construction timeline, even under optimal conditions, stretched well past any plausible end-of-war date. Meanwhile, the strategic situation was shifting. By mid-1943, the Battle of the Atlantic was turning decisively in the Allies' favor. New tactics, new technologies, particularly improved radar, the cavity magnetron, and the breaking of German naval codes, were sinking U-boats faster than Germany could replace them. The May of 1943 is remembered by German submariners as Black May. 41 U-boats were lost in that single month, and Admiral Dönitz temporarily withdrew his fleet from the North Atlantic entirely. The problem that Habbakuk had been designed to solve was, with extraordinary speed, solving itself by other means. The escort carrier program, too, had accelerated dramatically. By late 1943, mass-produced escort carriers, built on standardized hulls in American yards with production line efficiency, were becoming available in numbers that would have seemed impossible 18 months earlier. The Kaiser shipyards in California were producing a completed escort carrier every week by the end of 1943. Each vessel was cheaper, faster to build, and more tactically flexible than any Pykrete behemoth could ever be. Habbakuk was formally stood down in early 1944. The Patricia Lake prototype, left to the mercy of the Canadian summer, sank gently to the bottom of the lake, where it remains to this day, one of the most extraordinary war graves in the world, a monument to an idea too large for the war that produced it. The legacy of Habbakuk resists simple summary. As a weapon, it was never used. As a piece of engineering, it was never completed. and yet dismissing it as a failure requires a kind of willful blindness to what it actually represented. The Pykrete concept produced material science insights that outlasted the war. Research into composite materials, substances where two components combine to produce properties neither possesses alone, was advanced substantially by the Habbakuk work. The basic principle that Pyke identified, that fibrous inclusions could transform a brittle material into something ductile and strong, is now a commonplace of materials engineering. It appears in modern carbon fiber composites, in reinforced concrete, and in dozens of other applications that owe an unacknowledged debt to a man who kept mice and fed them wood pulp. The concept of the floating airfield itself, meanwhile, never quite died. The American Navy's mobile offshore base concept, developed in the 1990s, proposed linking together semi-submersible platforms to create temporary floating airfields in contested waters. A direct conceptual descendant of Habbakuk, built from aluminium and steel rather than ice. The sea base and a float-forward staging base proposals that have circulated in American military planning since the 1990s are, in essence, Pyke's idea in modern dress. Habbakuk also contributed, in a broader sense, to the emerging culture of unconventional thinking that would come to define British special operations during the Second World War. The willingness of Mountbatten's combined operations to entertain ideas that orthodox military planners would have dismissed out of hand. Pyke's proposals, the Mulberry Harbours, the Pluto pipeline under the Channel, reflects an institutional culture that valued creativity alongside competence. Not all of these ideas worked. Some were disasters, but enough of them worked well enough to matter. And the habit of mind that produced Habbakuk also produced innovations that changed the course of the war. The Patricia Lake prototype can be visited, or at least located, today. Divers in Jasper National Park have explored its remains, which lie in roughly 25 meters of water and are surprisingly well preserved, given that Pykrete, once submerged in cold water, maintains its integrity far longer than simple ice would. A small plaque near the lakeshore marks the location. Most visitors to Jasper National Park walk past it without knowing it is there. Return for a moment to December 1942 and that sinking merchant vessel. Return to the water temperature of 4 degrees, the condor banking away, the wolf packs forming in the dark. The men who conceived Habbakuk looked at that situation and refused to accept the constraints that defined it. Steel was scarce, so they proposed building without steel. Ice was brittle, so they invented a new material to make it strong. The mid-Atlantic was impossible to defend, so they proposed dropping an airfield in the middle of it. Each of these answers was, in its way, correct. The material existed, the physics worked, the prototype floated and held and demonstrated everything the planners hoped it would. What defeated Habbakuk was not imagination. What defeated it was time. The war did not wait for a 2.2 million ton Pykrete aircraft carrier. The war found other solutions: radar, code breaking, escort carriers built in their hundreds by men working 3 shifts in California shipyards. And those solutions closed the air gap before Habbakuk could. This is not a failure of imagination. It is a success of exactly the kind of industrial and intellectual mobilization that the Allies were capable of when pressed hard enough. But consider what Habbakuk required its designers to believe. It required them to believe that a vessel 20 times longer than HMS Queen Elizabeth could be manufactured, essentially, from the surface of the ocean itself. That a cheap, abundant, almost worthless material, water, could be transformed by the addition of wood pulp and cold into something capable of absorbing torpedo strikes and landing Spitfires. That the answer to Germany's most dangerous weapon was not a better gun, a faster ship, or a smarter bomb, but a different way of thinking about what a ship could be made of. Geoffrey Pyke died in 1948 by his own hand in a bedsit in London. He left behind a body of work so eccentric and so various that no single account of it has ever done it full justice. He was brilliant and difficult and largely unrecognized in his own lifetime. The mice are gone. The kitchen freezer where Pykrete was first tested is gone. The memorandum that started everything is in an archive, read now mainly by historians. The ice ship is at the bottom of Patricia Lake, 25 meters down, in the cold, dark water of the Canadian Rockies, surrounded by mountain and silence. It is made of wood pulp and water. It weighs approximately nothing compared to what it might have been, but it floated. That, in the end, is the only thing that matters. It floated, and in floating, it proved that the impossible was merely a question of materials.